Okay, so you said 3 on top?
Yeah.
How'd you get that?
Find the square root of 9.
Okay. So you went ahead and did this. Right? Okay. Now, someone please tell me what I should do next. Pierre?
Multiply square root of 15 over the square root of 15.
And that's called, what's that called again, guys? Is that weird word? Rationalizing the denominator. Because we don't want square roots in the bottom. So when we do that, we get 3 root 15 over the square root of 225, which is going to be 15. Should I leave it like that?
No.
Someone raise your hand. Please tell me what's the last thing you should do, Colby.
The top one makes the bottom 5.
Yeah, that should simplify to 1/5. Or you can just leave it as root 15 over 5, which is probably what I would do. Okay. So let's get rid of that k squared. What would that end up being in the numerator?
Oh. K root 3.
And the bottom we have 4 root 5k. Anything else we can simplify? No, unfortunately. So what should I do next? Catherine? Rationalize it. And what should I multiply by? Square root of 5k. You do not need to multiply by 4. 4 is not a problem. So then, remember, inside multiplies inside, outside multiplies outside. So we should be left with, let's see, k is still on the outside. On the inside now, what do we have? 15k. And then on the bottom, you still have 4. But we're multiplying 5k by 5k, which give me 25k squared, which is going to be 5k. So times 5k. So let's simplify that one more time. K root 15k over 20k. What's the last thing that I can simplify, Luke?
K. You can get rid of k.
Yeah, cross them out. Cancels it out, right? K divided by k is 1. So you are left with root 15k over 20. Let's have a quick discussion. You cannot simplify this any further. Do not tell me that this is root 3k over 4. Why can I not do that? What's bad about that, Sophic?
Because it's in the square root.
Yeah. Remember, it's like oil and what we say, water. You can't try and simplify these two things that are not alike. One's in radical, one is not. So keep them separate, please. Okay. So that is all we can do. If we are going to add and subtract, I guess, the radicals, meaning the insides, must match. This is the same thing, guys, as we've done before with combining like terms. So, for example, if you have 5x plus 3y plus 2x, which ones are like terms, Owen?
X.
The x's, right? Because their variables are the same. So the number in front doesn't matter. What matters is the thing that's after it. And so just like I can combine these because their variables are the exact same. So this is 7x plus 3y. Same thing goes for radicals. If I have 2 root 3 plus 5 root 4 plus 3 root 3, these are my like terms because they have the same radicand. The number underneath the radical is the same. So this would be 5 root 3 plus 5 root 4. So just keep in mind that the insides have to be the same in order to add or subtract them, to combine like terms. Just like we keep the x the same, we're not going to add the x or make it x squared. Keep the inside the same. You're going to combine the outside numbers. just like you would any other time you combine like terms. So this is the same thing as having 2 root 6 minus 1 root 6. Are my radicands, are the numbers the same on the inside of the radical? Yes, so we can combine. 2 minus 1 is 1. So it's going to be 1 root 6, or you could just write that as root 6. These are like terms, so you can combine them. They both have root 2. So negative 3 root 2 minus 3 root 2. Keep the insides the same, so it's going to be something root 2. What's going to be on the outside, guys? Negative 6. Good. You're going to have an expression like this, and the first thing that you need to do is simplify it, and then see if you can add or subtract, because as is right now, no, you can't simplify it, or you can't combine like terms, but if you maybe simplify these radicals, you might be able to, okay? So we can do it in a line like we've been doing, or since we have two 24s, you could just figure out how to simplify root 24. So as is right now, these are not like terms, so I'm going to simplify root 24 to see if I can get some like terms. Well, that splits up into the perfect square of 4 times 6. Square root of 4 is 2, so this is going to be 2 root 6. So we're going to go ahead and replace root 24s with 2 root 6. So 3 times 2 root 6 plus 3 root 6, keep that middle one the same, minus 2 times 2 root 6. So that would be 6 root 6 plus 3 root 6 minus 4 root 6. And we're going to add and subtract, so that would be 5 root 6, because these are like terms now. Looking at this problem as is, they're not like terms, so I'm going to simplify root 45 because I know I can. Well, that would break up into the perfect square 9 times 5. Well, square root of 9 is 3, so it's going to be 3 root 5. So now we can change it, so negative 3 root 5 minus 3, well, root 45 is 3 root 5, so times 3 root 5 minus root 2. Let's rewrite that again. Negative 3 root 5 minus 9 root 5 minus root 2. That would be negative 12 root 5 minus root 2. These ones are not like terms, and so you have to leave it as is.